All right, so now we're going to talk about some of the supplementary ideas you may want to implement into the home chapter 2 unit after you got through the first lessons there. As I mentioned in the previous video, you might want to skip 2.6 and 2.7, or at least just briefly go through those and then do a lot of supplement activities, because static charges and Coulomb's law is briefly mentioned in a read-in in activity 2.2, but there's not a lot of content given for students, and there's some important stuff that they need to know. So, it mentions charges and Coulomb, but it doesn't go that much into it. And there's a big component that students need to know about that in the standards, as well as how they're going to be tested at the end of the year on the MCAS. So you definitely want to go into a few things with a bit more detail. Home 2 covers a lot about current electricity, but we need to go a bit more into static electricity and a little bit more into electromagnetism. So I'm going to give you a few ideas, a few things that I've used. All right, so the main things they're going to need to know about static electricity, and most students are familiar with the term. Most students have gotten a shock when they walked across a carpet and touched somebody or something metal, or have gone down a slide and felt that buildup of static electricity. So they're familiar with the concept, but some of them are not so familiar with what it actually is or how it works. So the main ideas you want them to come away with initially is that this is a buildup of charge on materials that don't easily allow the flow of charge. So that's why the charge just sits there. That word static means, not to move. They may recall static friction and the use of the term static. So static friction before it moved. So same thing here, static electricity not before, but static electricity meaning that it's not a flow like current electricity. If you think of a current in water, that's a good analogy when you're teaching your students current electricity, a current in water, the flow of water, like in a stream. Same thing here. So this is static, just sitting there. And on certain materials, such as like a rubber balloon, that doesn't really allow that flow of charge. The charges can just kind of sit on that rubber material. And then opposites attract and the same charges will repel. So there's a few good things to use. And a magnet, if you have some magnets, and students are familiar with this, they've played with magnets before, and that, trying to touch the same poles of a magnet together, they push away and opposites attract. So that's a good analogy you could use for that concept. Of course, physics classroom has a lot of content on there about static electricity, so you can look at that and maybe pull some things off that to use with students. And of course, there's a ton of video clips that you could look at with your students that go into what static electricity is. And then there's a lot of demonstrations. Here's a few that I've used: the empty soda can roll, the dancing paper or cereal, like Rice Krispie cereal, bending water. All you really need is a balloon, somebody's head with some hair to build up the charge on, and do these demonstrations. So there's a lot out there. Look it up. You'll find a ton of things to show students, or even give students balloons and let them try themselves, as I often done in my classroom. All right, so there's a lot out there to get these two basic ideas across to students. Of course, if you happen to have a Van de Graaff generator in your building, we happen to have a teacher has one, and all the physics instructors borrow it from time to time when they go through this. That is a ton of stuff you can do with a Van de Graaff generator. A lot of cool demonstrations, a lot of different things you could do, from the magic pie plates to lighting up a fluorescent bulb to obviously the famous hair, to just shocking your students. They always love that. But so if you get a hold of that, that'd be great. If not, maybe you could show a video about it or whatever. Our science museum in Boston has a huge one. Students may be familiar with. When I show a Bill Nye clip about it, they all like that, because most of them been to the science museum. They recognize, that giant generator, Van de Graaff generator that they have there. FET has a lot of cool demos that deal with static electricity and charges. The balloon, John Travoltage, gotta love the play on words here, charges and fields. Electric field hockey here on the end, I'm going to show you briefly because I really like this one, especially when you get to the next topic, Coulomb's law. So students need to know this concept. This is on their formula sheet, but thankfully, once again, they don't have to compute this formula, but they do need to know what it means. Once again, this is very similar to the force of gravitation. You can see the formula is very similar. And it's basically, closer two charges get, the lot stronger the force is going to be between them. The farther, a lot weaker, again, because distance is squared divided by a square. So again, using the magnet analogy, holding the magnets, or even demonstrating with a balloon and some Rice Krispies, the closer, the more Rice Krispies will be attracted. Of course, building up a charge on this balloon first, and the more charges, the stronger that force. So the more times they rub the balloon on their head, they should be able to pick up more cereal. So you have students try that and talk about what that means, what happened in regards to this formula, and what this formula shows them. And of course, I really like electric field hockey. If you have access to computers, and they could use this simulation at FET. Let me show you it real quick. So it's pretty simple. They get to pull charges and see that the same charges will repel. You can see that vector arrow where it's going to go, and opposites will attract. Okay, so basically they just try to make the charge go into the goal here, and there's different levels that they can try. There's level 1, 2, 3, so on and so forth, and it gets just harder and more complicated, and they have to use more charges and try to figure out how to do it. So students love this challenge, and I think it's a lot of fun and good reinforcement of Coulomb's law. So something you may want to try there. You're going to want to do a bit more on electromagnetism, motors, generators, electromagnets. Basic idea here, changing a magnetic field will create an electric current, and vice versa. If you have an electric current, you're going to be able to create a magnetic field. A good way of showing that is just hooking up an electric current, a battery, and a wire, and bringing a compass near it, and they should see the needle move as the current goes through there. And then if you have a galvanometer, just make a wire loop, maybe around like an empty toilet paper tube, and just take a magnet through it and back and forth, and students should see a slight movement there, showing a very small electric current generated. And then build in a simple electrical magnet, and 3 ways to make it stronger, having students experiment, add in a nail, iron core, using more coils, using more current, add in a stronger or more batteries up to it. And then a simple motor. You can see a very easy way to make a simple motor here, using some very simple materials to get a magnet, a battery, a bit of wire, and a loop. Just little things you could do with your students to emphasize this concept that they need to know. Of course, there's a ton of PowerPoints that give them some explanations, and a lot of videos and demos you can do. And if you have those hand generators, you can talk a bit about how those work, the motor and the generator, how they're kind of, opposite one another. So yeah, that's a couple things I like to do with my students, because they will usually get about 1 or 2 questions on the MCAS regarding these things. So I like to supplement and add that in. So that's something you may want to do. And then that'll take you right up to your challenge with the students. And of course, I recommend that you supplement with some review of the concepts, and of course just a regular standard test there with students, pulling some questions off the MCAS, the current electricity and the static electricity questions you'll find there in the MCAS to give the students, just get them used to that type of exam and what they're going to see at the end of the year. All right, so hopefully that gives you some ideas you can use with your students to add to the curriculum to give them a little bit more content that wasn't really emphasized in active physics.